Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring quadratic functions which are written in standard form. Before we get started, let's look at a couple of definitions. So a quadratic function is any function of the form f of x equals ax squared plus bx plus c, where the leading coefficient a is not zero. The solutions to a quadratic function will form a U-shaped graph called a parabola. Now, every parabola has a vertex. So for any quadratic function of the form f of x equals ax squared plus bx plus c, the turning point or the vertex occurs at the ordered pair opposite b over 2a, comma f of opposite b over 2a. Parabolas also have x-intercepts and y-intercepts. Now, the x-intercepts, sometimes referred to as the zeros of the function, occur where f of x is equal to 0. So to find the x-intercepts, you let y equal 0 and solve for x. The y-intercept occurs at f of 0. So to find the y-intercept, you let x equal 0 and then solve for y. Now we're going to practice all of these formulas here in just a minute, and you'll see how they come together and work to help you find the critical attributes of a parabola. So let's consider the quadratic function f of x equals x squared minus 2x minus 3. Find each of the following. In part A, they want you to identify the zeros or the x-intercepts. In part B, they want you to identify the y-intercept of the function. In part C, they want you to identify the vertex of the function. So let's start with part A, identify the zeros of the function. So to identify the zeros of the function, or the x-intercepts, we take the function and we set it equal to 0. And then we solve for x. Now, the quickest way to solve this equation for x is to use factoring. So to get our first term x squared, we would have to use x times x. To get our last term 3, there's only two things that'll multiply together to give you 3, and that's 1 and 3. And we need that 1 and 3 to add up to negative 2. So that means the 3 will be negative and the 1 will be positive. After you have factored the function, then you take each factor and set it equal to 0 and solve for x. So here we have x equals negative 1. Here we have x equals positive 3. So our x-intercepts, or our zeros of the function, are at negative 1, 0 and positive 3, 0. Part B, they want us to identify the y-intercept of the function. Now, in our definitions above, it says to find the y-intercept, you're going to let x equal 0 and solve for y. So what we're doing is we're identifying the function at f of 0. And to do that, you're going to write down the function rule, but you're going to replace all the x's with parentheses. So instead of x squared, you'll put parentheses squared. And instead of minus 2x, you'll put minus 2 parenthesis and then minus 3. And then to find f of 0, you'll plug in a 0 here and here. So 0 squared is 0, minus 2 times 0, which is 0, and 0 minus 3 is negative 3. So our y-intercept is 0, comma, negative 3. So now we have found the x-intercepts and the y-intercept. The only other critical attribute we're going to find in this problem is the vertex or the turning point of the function. All right. So to find the vertex or the turning point, we're going to use this formula that we talked about up here. The vertex is an ordered pair, and we find the x value by using the formula opposite b over 2a. So before we start this problem, it's helpful to identify the value of a and b. So in this equation, the value of A is 1, and the value of B is going to be -2. All right, so let's write down our formula to get the x-intercept of the vertex. It is opposite B over 2 times A. So we have the opposite of, and I'm going to replace all the variables now with parentheses, and then I'll plug in A and B. So for B, we would plug in a -2, and for the A, we would plug in a +1. After you get that plugged in, then you're going to evaluate that. The opposite of -2 is +2. 2 times 1 is also +2. And 2 divided by 2 is 1. So now we know the x-coordinate of our vertex is going to be 1. So 1 comma something. To find the comma something, you're going to evaluate the function for that x value, which was 1. So we're going to find f of 1. Now to find f of 1, I'm going to write my function down, but I'm going to replace the x's with parentheses. So parentheses squared minus 2 parentheses minus 3. And I'm finding f of 1, so I'll put a 1 there and a 1 there. All right, so 1 squared is 1. 2 times 1 is 2, and then minus 3. So 1 minus 2 is -1. -1 minus 3 is -4. So now we know the y value of my vertex. All right, let's try that with another function. Example 2. Consider the quadratic function f of x equals -x squared plus 8x minus 7. Find each of the following. Let's start in problem A by identifying the zeros or the x-intercept. So to identify the zeros, I'm going to make the equation equal to 0. So -x squared plus 8x minus 7 is equal to 0. Now, when I'm factoring something where the first term is a negative, I like to divide that -1 out. So if I divide out a -1, what that's going to do is change all these signs to x squared minus 8x plus 7 equals 0. It's a lot easier to factor these when you pull that negative out. So then we have -1, parenthesis. So to get an x squared, I would need an x times an x would give me x squared. To get a 7, the only thing I could use is 1 times 7, so I'll go ahead and place those there. But I need the 1 and the 7 to add up to -8. So the only way I can get a 1 and a 7 to add up to -8 is to make them both negative. All right, now I'm going to solve these for x. So my first x-intercept would be +1, 0. My second x-intercept would be +7, 0. So there's your x-intercepts. All right. Now, to get the y-intercept, you're going to evaluate f of 0 because the y-intercept is 0, something. So we want to identify f of 0. So I'm going to replace all the x's with parentheses and then plug in a 0. All right, so that gives me 0 squared is 0, so that gives me -0. 8 times 0 is 0, and then minus 7. So -0 plus 0 is 0. 0 minus 7 is -7. So my y-intercept is 0, -7. Now, the last thing they want us to find in this problem is the vertex. So to remember to get the x-coordinate of the vertex, I need to use this formula, opposite B over 2A. Now, in this problem, I should probably write this down. Let me put it in a different color here. The value of A is -1, and the value of B is +8. So those are the values we're going to be using for the formula. So now let me replace the variables with parentheses. And I will plug in an 8 for the B and a -1 for the A. And then we'll evaluate that. The opposite of +8 is -8. 2 times -1 is -2. -8 divided by -2 positive 4. So I know my vertex is 4 comma something. Now, to get the comma something, we want to now evaluate the function for f of 4. So to do that, I'm going to replace all of my x's with parentheses, and I'm going to plug in a 4. So I'll put a 4 here and a 4 here. All right, so remember your order of operations. We want to evaluate our exponents for it first. So 4 squared is the same thing as 4 times 4, which is 16. 16 times negative 1 would be negative 16. 8 times 4 is 32, and then minus 7. So negative 16 plus 32 is positive 16, and then we have minus 7. So 16 minus 7 would be 9. So our vertex of this function would be 4 comma 9. Now, in our third example, we're going to take everything we've learned so far, and we're going to use our critical attributes now to actually construct the graph of a quadratic function written standard form. So in example 3, we have the function f of x equals negative 2x squared plus 16x plus 40. So they want me first to determine the vertex algebraically. So to determine the vertex algebraically, remember we start by finding x, and we use this formula, opposite b over 2a. Now in this problem, our a value is negative 2, and our b value is 16. So I'm going to replace these variables with parentheses. And then I'll plug in, for b, I will plug in a 16, and for a, I'll plug in a negative 2. All right, let's evaluate that. The opposite of positive 16 is negative 16. 2 times negative 2 is negative 4. And negative 16 divided by negative 4 is positive 4. So I know my vertex is going to be at 4 comma something. Now to find the comma something, I want to evaluate the function for f of 4. So I'm going to replace all of my parentheses, all of my variables with parentheses. So negative 2 parentheses squared plus 16 parentheses plus 40. And I'll plug in a 4 here and here. Now, when my numbers are this big, I usually use my calculator. So I've got Desmos handy to kind of show you how I would type this in. I would put negative 2 and then an open parenthesis, 4 close parenthesis squared, plus 16 parenthesis 4, plus 40. So you can see our answer is fairly large here. So f of 4 is equal to 72. So I know the vertex of this function is going to be at 4 comma 72. Now, to get the zeros of my function, I'm going to take the whole entire function and make it equal to 0. Okay, now we're going to find our zeros by factoring, but the first thing I want you to notice is that we have a common factor of negative 2 that needs to be divided out first, because the numbers that we have right now are really large, and you really don't want to factor when the numbers are really, really big, if you can avoid it. So I'm going to factor out a negative 2. So negative 2x squared divided by negative 2 gives me just x squared. 16x divided by negative 2 gives me negative 8x. And 40 divided by negative 2 gives me negative 20. Okay. Now we can factor just what is inside the parenthesis. So for x squared, I'll use x times x. Now for 20, I could use 1 times 20, 2 times 10, or 4 times 8. But since I'm trying to get a negative 8, as my middle term, that means I'm going to need to use 2 and 10. So I'll put a 2 here and a 10 here. Now, to get those to add up to -8, I would have to make the 10 negative and the 2 positive. So this means I'm going to have x-intercepts at -2, 0, and 10, 0. So there's my 2 x-intercepts. Okay. Now, part C says to sketch and label the parabola using the zeros and the vertex. So I am going to label this graph here. I'll put my first x-intercept right there at -2, 0, and then 1, 2, 3, 4, 6, 7, 8, 9, 10. Here's my second x-intercept. So there's my 2 intercepts. My vertex is at 472. Now, we're just making a rough sketch, so I'm not really going to scale the y-axis. I want to go 1, 2, 3, 4, and then way up here somewhere, I'm just going to put that and label it as 4, 72, instead of scaling. Now, I'm going to do this as neatly as I can. It's kind of hard on my iPad, but it's going to look like this, a U-shaped graph when you're done. So 4, 72. Maybe I should label here these intercepts so you can see how we use them to create that sketch. Okay. All right, let's look at example 4. An object is fired upward from the ground with an initial velocity of 88 feet per second. And I do believe that was supposed to say 80 feet per second. Its height in feet above the ground as a function in time in seconds is given by the equation, and let me highlight it for you. H equals -16t squared plus 80t. Sketch a graph of this object's height for all the times where t is greater than or equal to 0 and where height is greater than or equal to 0. Label the object's maximum height, the time it takes to reach this height, and the time at which it returns to the ground. So step 1, we're going to find our x-intercepts and plot. So to find the x-intercepts, you take your function and make it equal to 0. So -16t squared plus 80t is equal to 0. Now, to solve this by factoring, I'm going to have to take out the greatest common factor, which is -16t. So that would leave me -16t squared divided by -16t would leave me t. 80t divided by -16t would leave me -5. Now, if I set these equal to 0 and solve them, -16t equals 0. If I divide both sides by -16, I get t equals 0. And t minus 5 equals 0, I get t equals 5. So our x-intercepts are at 0, 0, and 5, 0. So it says to find the x-intercepts and plot. So here's our 0, 0, and then 1, 2, 3, 4, 5. So 5, 0. All right. All right, next thing they want us to do is to find the vertex. So to find the vertex, we need to know that in this problem, the a value is -16 and the b value is +80. So if we use this formula for the x value, opposite b over 2 times a, we get opposite parenthesis over 2 parenthesis, plug in at 80 for the b and a -16 for the a. So this would be -80 over -32. Now let's see what that simplifies to. Not 22, I want 32. Okay, 2.5 2.5 seconds. Okay, so this is going to be, we know our vertex is going to be 2.5 comma something. Okay, we just need to get the comma something. So to do that, we're going to evaluate the function for f of 2.5. Now to do that, I will replace the variables with parentheses, and I'm going to plug in the 2.5. Now I would definitely do this one on your calculator because there's a good chance of making a mistake, a math mistake on this one if you're not careful. So negative 16 parenthesis 2.5 parenthesis squared plus 80 parenthesis 2.5. So that gives us 100. So f of 2.5 is equal to 100. So there's my vertex. Let me box that in. You know, I should probably go back and box in the x-intercepts too. Now they want us to plot our x-intercept. So just like the other one, I'm just going to approximate the y value. So 2.5 would be about right here. Go up. I'm just going to put a dot up here somewhere, and I'll label it 2.5, comma 100. Now, the last thing they want us to do is to form our parabola. So there is our parabola. Now we're going to answer these questions. The object was launched at a height of how many feet? So the object was launched right here at 0 seconds. And notice that when it was 0 seconds, we had a height also of 0 feet. Now that should make sense because I do believe the problem originally told us that the object was fired from the ground. So that would be 0 feet, all right? The object reaches a maximum height of blank feet. So look at your graph and see what you think the maximum height is, all right? Did you say 100 feet? And that occurred at 2.5 seconds. And it returned to the ground after 5 seconds. So for our domain, we want to go left to right. So that would be 0 seconds all the way to 5 seconds. For the range, we want bottom to top. So our smallest height was 0 feet. Our maximum height was 100 feet. And that concludes today's lesson, Standard Form of a Parabola.